this one. We also, I don't know if you guys did, like, I don't know if you guys did 69 already, but that one would also be really helpful if you could go over that one.
The straight line depreciation, you prefer 69 versus 72? That's fine.
Yeah, no, I wanted to see the graph too, but I think 69 is a little bit different, so.
Okay, so let's start with 69 then. In 69, again, we have straight line depreciation. So please open on page 45. So 69 on page 45 in Multimedia Library, and this is chapter R, and then section R.4. So the quick copy buys an office machine for $5,200 on January the 1st at a given year. Fine. The machine is expected to last for 8 years. So when I read the problem, I take some notes. So it says January 1st, so 0,5,200. So at the moment it was bought, 0 time $5,200. So this is cost, of course. And it's supposed to last, they say, for 8 years, which means 8 years from now, the value of the machine, whatever that is, the copy machine, should be 0. So cost in this case, or value. So the value, once I'm told that it should last for 8 years, then it means that the value, if that's what they're looking for, I didn't finish reading anyway. So it's supposed to last for 8 years, which means it is depreciated. It doesn't mean that we have to throw it away or sell it, but the value after 8 years is supposed to be 0. Okay, let's read on. At the end of which time its salvage value will be, so it's not 0. It's 1,100. Fine. If the company figures the decline in value to be the same each year, then the straight line depreciation value, V of t, after t years, between 0 and 8, fine, is given by V of t equals C minus t in parentheses, C minus 5 divided by n. And let's see what they are telling us about all these. They say when C is the original cost of the item. So C equals 5,200. Then T is the time, I'm sure. N is the number of years of expected life. So it's expected to last, so N equals 8 years. And S is the salvage value. It's not in the formula. V of t is also called the book value. Okay, so this is book value. Perfect. Find a linear function for the straight line depreciation of the machine. So
is that
yes,
minus 5 or is that minus s?
You know what? I thought it was 5. So
Okay,
it is S. Okay, thank you very much. So S, indeed. My printer, for some reason, it just fades a little bit, the letters. I'm not sure why it does that. Oh, maybe it's intentional from the publisher. I'm not sure. Salvage value. Okay. So the salvage value is given to us, which is 1,100. All we have to do at this point, so this is part A, they're asking us to find this function. They're giving it to us in a roundabout way, if you want, in a hidden way. We just have to plug in everything and create a function that is linear. According to the model, it says find the linear function for the straight line depreciation of the machine. So V of t equals C, which is 5,200, minus t, which is the variable, it's time. C again is 5,200, and minus s, which is given to us as 1,100. Everything divided by n, which is 8 years. So then V of t I'm going to divide by 8 after I subtract, of course, and divide by 8, and I got 512.5. So 5200 minus 512.5 T, and this is the linear depreciation. Part B. Find the book value of the machine after 0, 1, 2, 3, 4, 7, and 8. Very good. We're going to create a table. We don't want to repeat this process indefinitely like they want us to do. So I'm just going to copy 0, 1, 2, 3, 4, 7, and 8. We know the answer for 8. We know the answer for 0. We can already put it in. So 5200, it should be an 1100. We'll check everything. So let's go back to the graphing calculator and go to y equals. I didn't mean that, I meant this. Clear if you have anything else and put in this function. The correct order is negative 512.5 T plus 5200. That's the correct way in descending order. So I'm going to write negative 512.5 x, because I don't have T in the calculator, plus 5200. Stop me if you have any questions on this. And then we go to second and table. And Baki and Daniel and Jack, please join us, please. And I'm going to plug in 0. And I have to get 5200. I need to plug in 1. And I will get, and it's good to highlight and make sure that everything is in there. So 4687.5. I'm going to plug in 2. So the table, the independent variable has to be in ask mode, so you can put in the values you want. So 2 is already in there by chance, 4175. 3 is already there, again by chance, 3662.5. 4, and then 7, and then 8. So 4 gives us 3150. And 7, it gives us 1612.5. And of course, 8 has to give us 1100. Otherwise, the function has a flaw. Any questions so far? Any questions? Okay, so this was 69. I don't know if we still want to do 72. We are given the function, and that is the book value of a photocopier, which is the same idea, 2 years after its purchase. And maybe we just read it quickly if we want to go back. What do the numbers negative 700 and 3500 signify? How long will it take the copier to depreciate completely? And what is the domain? So is it a yes for this one or no? You choose.
Yeah, sure.
Okay, very good. So let's look at 72. So we are given, so this is 72 on the same page. Here's the graph. It starts here at 3500. We're not going to read from my graph. And this is 5, and of course this is time, number of years of use. And this is the book value. Book value. Okay, here's the first question. We have the function. They're giving it to us. So we don't have to determine it. So it's negative 700t plus 3500. Okay, so let's read the first question. What do the numbers negative 700 and 3500 signify? That's our first step. So what does negative 700 represent, and what does 3500 represent? Can anyone say anything about those numbers? Anyone?
$3,500 is the initial cost.
Very good. Value. Great job, 3,500. And what about negative 700? And what is the measurement unit?
Is that the depreciation?
Yes. So this is the rate of change of value per year. Since it's a negative value, it's dollars per year. So it's a decrease. The measurement unit of any rate of change consists of two measurement units. The measurement unit for the y variable, that is y, over the measurement unit of the x variable, which is time. So this time is in years. Very good. Part B. How long will it take for the copier to depreciate completely? What would you say? How long it takes, according to this function, to depreciate completely? And the final question is the domain. So how many years? If it starts with a value of 3,500 and it drops to 0, how many years it needs?
5.
Yes. In 5 years. And what will be the domain of this function? Because we're talking about time, you cannot say negative infinity to infinity. The function actually starts here and ends here. And we cannot have a negative book value. So what will I say about the domain of this function? Between?
Between 0 and 5.
Very good. Thank you very much. Okay, moving on. Would you be interested in 77, the organic food sales? I selected that problem because we had some situation with the average rate of change. So maybe this is a quick review of the average rate of change. So let's do that. So 77 on page 46. As you see, we're given 2 points. 1 point is 2001, comma 50. No, it's this dollar sign 74. 7.4, and the other one is 2013 and comma 29. So let's read the question. Find the average rate of change of organic food sales in the United States. And the x variable is time or year, and the y variable is in billions of dollars. Okay. So the average rate of change. Can anyone give us the formula for the average rate of change? Anyone?
Is it isn't it f of b minus f of a?
Correct. Very good.
Okay.
F of x2 minus f of x1 over x2 minus x1. Perfect. Thank you. So the numerator will be 29 minus 7.4, and the denominator 2013 minus 2001 is 12 years. And let's divide after, of course, after you subtract 29 minus 7.4, press enter, and then divide by 12. And I got 1.8. We have to state the measurement unit. Without the measurement unit, 1.8 doesn't mean anything. Can anyone give us the meaning of the rate of change and also the measurement unit? And then we can look at reaction time. Another problem that I would like to look at if you want to.
Is it billing for you?
Thank you very much. Excellent. And what does it mean? Since it's a positive number, what will you say? That the organic food sales increase at a rate per year, at a rate of 1.8 billion per year. So the sales increase. Why increase? Because it's a positive, at a rate of 1.8 billion per year. I think we had enough examples, but would you like to look at reaction time? It's another, I think, interesting situation. While driving a car, you see a child suddenly crossing the street. We never want to see that, ever. But your brain registers the emergency and sends a signal to your foot to hit the brake. The car travels a reaction distance d in feet during this time, where d is a function of the speed r in miles per hour that the car is traveling when you see the child. The reaction distance is a linear function given by. Interested or not? Anyone?
Yeah.
Okay. Well, I'm hoping that at least some of you are paying attention. So d of r equals 11r plus 5 divided by 10. So the same thing could be written as 11r over 10, which is 1.r, plus 5 over 10, which is 0.2. 5. 0.5. 5 divided by 10. So it's up to you. You can use this, or you can use this. I prefer when I plug in the calculator not have to have a fraction, but it doesn't matter. I caution you on one issue, though. If you put it this way in the graphing calculator, you have to have parentheses around the numerator. If you put it like this, then you don't. Okay? So it's up to you. So they're asking us to find d of 5 of 10, 20, 50, and 65. These are all miles per hour, of course. So r in miles per hour, and the distance r, when d of r, when we drive at 5, at 10, at 20, at 30, at 50, or 65 miles an hour. I'm not going to do this by hand. Just going to put it in the graphing calculator as 1.1 x, not r, we don't have r, plus 0.5. And go to second and table and plug in these numbers. I want 5, and then 10, and then 20, and then 30, and then 50, and then 65. So here are our answers. And the distance is measured. We have to put the measurement unit always. So they are telling us is in feet. And the speed in miles per hour, of course. So the distance is in feet. Good. So I got 6, 11.5, 22.5, 33.5, 55.5, and 72 feet. Okay, so in the next, they're asking us to graph this function. No problem. Let's do it with the graphing calculator since we already have it in the calculator. So back to the viewing window. So we have to select a viewing window. We're talking about a rate. That's the independent variable, right? So the independent variable goes from from 0 till, I'm not sure, I'm gonna maybe consider 100 miles an hour. And what about the distance? Again, I'm not sure, but definitely when the speed is 65, the height is 72, the distance is 72. This is the point 65, 72. So I don't know how high. But I'm sure of one thing. I'm not interested in the negative side of y, and I'm not interested in the negative side of x. So x minimum 0. X maximum, I don't know. I put 100. The scale, I'm going to make it maybe 10. The y values, minimum 0. And maximum, again, I have no idea. I'm going to put 150 with a scale of 25. And let's see what happens. And let's graph. So what does this really mean? It means that the higher the speed, the longer the distance to brake. And what will be the domain? We're also asked to find the domain of this function. Could be anything from 0 to, I don't know, I don't want to say not more than 100 miles an hour or so, but it could be anything. Because it's a linear function, and linear functions are polynomial functions, are defined everywhere. And this completes, any questions for me, please? This completes section R.4.